Welcome to the course. This is Course 1. The structure of the course will include 3 modules, 2 videos for each module. You will receive handouts of each module. The goals that you need to achieve in the module will be outlined, and a quiz in each module to test your knowledge. Practice ideas are included too. Welcome to Course 1, Module 1, Understanding Development. This module will cover brain growth and development, stress and survival, basic anatomy of the emotion regulation system, reasoning ability, the function of emotions, emotional memory, developing a sense of self, psychological development, neuroplasticity, not one size fits all, the impact of temperament, genetics and biology, sibling rivalry, and when to be concerned. Brain growth and development. There are 2 prominent times of brain growth, the first 5 years of life and adolescence. Brain growth and development is shaped by genetics and environment. For a child, the earliest environmental factor to shape their brain development is the parent. Therefore, responsible parenting is very important to the healthy structural and functional development of your child's brain. Adolescence is another important time of brain growth. Adolescence also involves a process known as pruning. During this process, parts of the brain that are less utilized are clipped away, keeping parts of the brain that are used more often. It's important to assist your child in using and strengthening the best parts of their brain. Adolescence often marks the onset of emotional difficulties. This could be attributed to hormonal changes with the onset of puberty and the psychological pressures of establishing identity. However, it's believed that the pruning process within the adolescent brain exposes vulnerable areas of the brain that have previously been less evident, resulting in the onset of the emotional problems. Stress and survival. The body and brain have developed to ensure human survival and the progression of our genes. The brain is highly sensitive to any stress, threat, or danger. When stress is registered by the brain, it triggers the body's stress response system. This is called the hypothalamus pituitary adrenal axis, or for short, HPA axis. The autonomic nervous system, or ANS, is another important component of the stress response system of the body. The ANS is responsible for the release of adrenaline and noradrenaline that mediate the symptoms of anxiety, like rapid heart rate, shallow breathing, sweaty palms. The stress response systems, namely the HPA axis and the ANS, trigger the body's fight or flight response. Hormones and neurotransmitters such as cortisol, adrenaline, noradrenaline, and opioids are involved in this stress response system. This response keeps us safe from danger. Initially, parents are solely responsible for their child's survival. They provide their child with physical care, shelter, food, warmth, and emotional nurturance until their child is able to self-care. Any stress in a child's environment would trigger their stress systems. The parent is a major part of the child's earliest environment. Situations that cause a child to become stressed, anxious, or fear their survival, for example, a parent yelling, acting aggressively, being emotionally dismissive, or emotionally overwhelmed, would trigger the child's stress response systems and the release of the stress hormone cortisol. Cortisol suppresses the body's immune system, and it is toxic to brain cells. Cortisol causes death of brain cells, and in this way disrupts healthy brain development. Therefore, negative early life experiences disrupt the structural and functional development of the child's brain. It is these changes to the brain structure and circuitry that will underlie the development of problems with emotion regulation, attention, memory, and executive functioning. When children are constantly exposed to stress, their HPA axis becomes hypersensitive. In such cases, even a minor stress would trigger the body's stress system. At times, chronic stress might result in a burnout or a numbing of this stress system. People who have a numbed response to stress will often seek out more dangerous situations to achieve a sense of stimulation. People who have experienced past trauma of a chronic nature will often continue to re-expose themselves to the trauma for this reason. I will now discuss basic anatomy of the emotion regulation system. I like to use Dan Siegel's hand model of the brain to explain the basics of brain structure. Dan described the brain resembling a fist, with the thumb tucked inside the clenched hand. The attached arm is representative of the spinal cord, and the palm area adjacent to the wrist will represent the brainstem. The brainstem controls basic life functions like breath and heart rate, consciousness and being awake or sleepy. The emotion center or limbic system sits on the inside of the fist. The limbic system is responsible for emotional processing, motivation, learning, and memory. Within the limbic system sits a tiny structure, the amygdala, which is the brain's alarm. The amygdala gauges the degree of safety or threat in the environment, and it triggers the stress response system when needed. The body's alarm system is very old and primitive. It has kept our forefathers safe from real dangers. Unfortunately, this system cannot discern the degree of threat. Much of what is threatening today would not have been to the degree of threat that our forefathers faced, but it is as triggering for our body's stress system. We are experiencing the world through our 5 senses: sight, smell, touch, taste, and hearing. This information is sent via a processing center known as the thalamus to the emotion center, limbic system, for evaluation, and then to our upper brain areas, the cortical areas. The cortical areas are where we create the representations and stories of these life experiences. Reasoning ability. The frontal lobes, represented in the hand model by the overlaying fingers, are the foremost part of the brain and responsible for our reasoning ability. In children, the frontal lobes aren't yet fully developed and only complete development by the mid-20s. The foremost part of the frontal lobes is called the prefrontal cortex. There are connections that run from the prefrontal cortex to the limbic area that act as a top-down control mechanism of the emotions. This could be seen as the brake system of the brain on its emotions. Because the frontal lobes have yet to complete development, children and adolescents are biologically unable to be rational about their emotions in the way that adults do. Our ability to reason has developed through learnt experiences, and because children haven't had much experience, their perspective on an emotional situation is limited. When children become emotional, the prefrontal cortex goes offline. Dan Siegel has called this flipping the lid, as he shows how the hand opens, leaving the emotion centers exposed and in control of the child's actions. Hence, in very emotional states, children are biologically incapable of reasoning. The primary goal would be to soothe their emotions until the prefrontal cortex and rational thinking come back online. Helping children to regulate their emotions and use their reasoning will strengthen their brain's brake system circuits. Children become able to self-regulate and reason for themselves as they get older. Function of emotions. Emotions are an essential part of life. They provide richness and fullness to experiences that would otherwise be very dull. Emotions get people moving. Emotion. Example, you smell a rose, senses, and feel happy, limbic, and think it would be nice to pick this rose for your partner, and you do so, cortex. Sometimes emotions need an immediate response. For example, you see a dog running towards you, sight, sensation, you feel anxious, limbic, emotion, and then you run, action, cortex. In this situation, it would not be useful to think too much. The brain has a special circuit that can bypass the rational part of the brain, cortex. The emotional brain matures before the rational brain does, and therefore children don't inherently reason their emotions. It needs to be taught and developed. During adolescence, the emotional brain is maturing, and therefore adolescents use their emotional brain to make decisions, especially when emotions are heightened. For example, your teenager is excited about a party, intense emotion, but doesn't consider the consequences of the event, as reasoning ability is needed, but less active at this time. The reward system is also part of the limbic system or emotion center. Situations that offer a high degree of reward are appealing to an adolescent. A party would offer social rewards such as seeing friends. The adolescent's reward system is also very sensitive. Adolescents experience a much greater rush from rewarding situations. Adolescents also need more stimulation to activate their reward system, and therefore they inherently seek higher risk situations. Emotional memory. Children are experiencing the world via their 5 senses: smell, touch, hearing, sight, and taste. These sensory experiences are conveyed to the limbic area, and emotional responses are felt. Children store memories of these experiences and also create mental representations of these experiences that become coded in their cortices. Example, a mother warmly embraces her crying child. The child feels mother's touch, sensory, and feels loved, limbic area. The child will form a memory in the limbic area of this event and create a mental representation of their mother and her response to their distress, cortical. A negative experience would result in negative emotions and storing memories and creating mental representations of these experiences. For example, a crying baby is dismissed by the parent. The child feels sad and creates a mental representation of their distress, being uncared for by their parent. Children as young as 18 months are able to evoke a mental image of their caregiver that is used to self-soothe their distress. If the caregiver hasn't been attentive to the child's emotional needs, the image evoked by the child might further their distress. These are emotional learning experiences, and they occur constantly from an early age. Through these experiences, the child begins to learn about themselves and the world around them. They develop expectations of how their feelings will be managed by significant people in their lives. These experiences are laid down in the brain's circuitry and become ingrained by repeated patterns of similar relationships throughout life. Initially, our memories are not consciously formed. In the first year of life, a child is creating procedural memories of their experiences with parents. The child would not be aware of these events, but the feelings, behaviors, and body sensations of these situations would be recalled later in life, in any situation that might trigger these memories. After a year, a child begins to form conscious memories of situations. Because we have memories that are not consciously formed, we might infer that our emotions, thoughts, and behaviors relate to a current situation, rather than a memory of an earlier event that has been triggered by the present situation. This could result in us responding in old but familiar ways, and in this way, we establish repetitious patterns of behavior and ingrain brain circuits. Traumatic situations are typically not consciously remembered because children might dissociate in a traumatic situation. Dissociation interferes with the encoding process of memory formation.